everyone. This is the last part of this program. And for the lastly, the Professor Paul Yin will give a lecture on the topic of NASA's Mars mission. Professor Paul Yin, please turn on your mic and your camera, please.
Hi,
Hi, Professor
안녕하세요.
Paul
Hello,
Yin.
everyone.
Oh, Professor Paul Yin, I really miss you.
Okay, good to see you.
So can you explain yourself for the UAE and Korean students?
Okay, I am currently I'm a mathematician. I teach at El Camino College. I'm a mathematics professor in the United States of America. Since 2012, I've been serving as NASA Solar System ambassador. So my job is such as giving you a public talk, introducing NASA's missions. And then since 2015, I've been involving NASA's preparation to a human mission to the Mars. So also, my interest is also what lunar mission too. Today, my talk is about NASA's missions for last more than half centuries.
Professor, I heard that you are in the United States of America right now. So can I ask what time is it now in the Korean country?
The United States, this is like it's midnight. So we are 16 hours behind the Korea. So it is a midnight.
Wow.
I was a little sleepy, but I'm so excited finding so many passionate young scientists here
Really, thank
from
you.
both Korea and the UAE.
Really, thank you, Professor. And right now, we'll start your lecture.
Okay, thank you.
Thank you.
NASA Mars missions. Professor Paul Yun, NASA Solar System Ambassador. This is Paul Yun from Los Angeles, California, United States of America. Welcome. مرحبا Elsa. 반가워요. Contents. Chapter 1, Mars. Chapter 2, Mars mission goals. Chapter 3, exploration methods. Chapter 4, Mars mission from 1960s to 2020. Chapter 5, Mars 2020 Perseverance and Sample Return. Chapter 6, Landing Site. Chapter 7, Our Future. Chapter 1, Mars. 13.7 billion years ago, in the darkness, there was a sudden huge explosions, which we call Big Bang. This is how our story begins. 4.6 billion years ago, our solar system was born in Milky Way galaxy. Our planet Earth and Mars were born about 4.5 billion years ago. Mars has two moons, Phobos, fear, Deimos, demons. The average distance between Sun and Earth is 150 miles, kilometers, which is we call 1 astronomical unit. The average distance between Sun to Mars is about 1.5 astronomical units. Mars 1 year is 687 days, which is about 2 years. Mars diameter is about half of Earth, twice of our Earth's moons, about. Mars mass is way less than Earth, which is a good news because less attractive force, when you return home from Mars, we expect to use less energies. So here you see that Mars gravity is about 1/3 of Earth. So if you jump on Earth, you get this much height. But on Mars, you will jump higher because less gravity. Mars temperatures, average temperature negative 60 degrees Celsius, which is about the temperature inner part of Antarctica, right on Earth. And we know we have a lot of researcher down there. So temperature shouldn't be a problem for human settlements. Mars' atmosphere is way thinner than Earth, so about 1%, about 1%. Problem is, due to thin radiations, atmosphere, solar ray radiation and then cosmic radiation can reach to the surface of Mars very easily. So when you go to Mars, you need to watch out for strong radiations. On Earth, our air is made of 70% nitrogens, 21% oxygens. On the other hand, on Mars, most of the air in Mars is carbon dioxide. So CO2, right? So I guess you need to watch out when you go to Mars, make sure you wear a spacesuit when you do outdoor activity on Mars. Chapter 2, Mars mission goals. This year, NASA is spending $22.6 billion, which is about less than 0.5% of US federal budget. NASA, as a leader of the science, focus on discovering many secrets of the universe and continue researching for life outside of the Earth and try to protect and improve life on Earth. To achieve all this, NASA continue work on new innovation and advancement of technologies through the commercial partnership such as SpaceX and through international partnership such as UAE Space Agency and Korea's Space Agency, 한국 항공우주연구원, and 한국 천문연구원. And through all this effort, NASA continually inspire people in all ages. NASA involved public in space missions. Mars 2020, which is currently heading to the Mars, was named by 7th grader Alex Martyr. And Mars 22 companion, space helicopter Ingenuity, was named by 11th grader Vanessa Rupani. And we know that currently Mars 2020 is carrying more than 10 million passengers' name, including mine. I'm pretty sure some of you also send a name to the Mars through Mars 2020. And also as NASA ambassador, I continually reach out to public, teach next generation about space exploration. Here is my audience, Mars colonies map. NASA's long-term Mars exploration programs focus on determines whether life ever rose on Mars, understanding climate of Mars, understanding geology of Mars, so that we better understand our planet Earth. And then lastly, we prepare for human explorations to Mars. So how does NASA explore space? Method 1, flyby. Fly mine mean you don't stop to planet, but you just pass by, possibly taking pictures. Second method, orbiter. And this is a MRO, Mars Reconnaissance Orbiter, which is currently operating on Mars. And upon my request as a researcher, MRO satellite sent me this picture to me. This is the second method. Third method, lander. This is an inside lander. And then this is artificial drawing of the what? Mars 2020. So once Mars 2020 Perseverance arrive on Mars in February 2021, this is how it's gonna operate. Next one, Mars helicopter. This is fourth method. Sample return, bring the sample back to Earth. Next 50 years, NASA will focus on sample return, visiting many different planets and asteroids, comets. That's what NASA will focus. Bring the sample back home, Earth, so that we understand better. Eventually, the last method is human explorations. Number 4, Mars missions from 1960s to 2020. So here we go. Are you surprised that since 1960s, early 1960s, we sent this many spacecraft? At least we attempt. Did they all succeed? Not really. Green check mark mean successful mission. X mark mean failed mission. This is Soviet Union's, former Soviet Union's, blue lines of United States, Russia, Japan, European Space Agency, and India. You notice that most Soviet missions failed. On the other hand, you see that most of the NASA's missions were successful. And then NASA is the only one. Here's a level here, flyby and orbiter lander. Lander and rover, these are very challenging. Only NASA have been successful sending, landing on Mars. Let's focus on this year. This year, July 2020s. Currently, NASA's Pathfinder, the Perseverance, Mars 2020, is heading to the Mars. And the UAE Space Agency is sending orbiter, and Chinese Space Agency sending spacecraft containing orbiter, lander, and the rover. So every 26 months, Earth and Mars get close enough so that we could get to the Mars. This is called Hoffman transfer orbit, so that we could get to the Mars with least amount of energies. So this July, UAE Space Agency launched orbiter named Al-Amal, which means hope, to understand a daily and seasonal weather cycle on Mars and understanding dust storm. This is important for our human expeditions in the future. We need to know this information. So I'm sure what Amal will find out will be very helpful for future human mission to the Mars. And Chinese Space Agency sent spacecraft, orbiter, lander, and rover together, combined. And then NASA sent out Perseverance, which is a rover and helicopter. And focus will be on finding whether life ever arose on Mars and sample return and preparing for human missions. So you know that missions always, every mission must have their own mission purpose. So NASA's strategy is NASA has been following water. Why? Because water leads to indicating habitable environments. On Earth, wherever water is, we know there life is. So that's a place where we could find the evidence of life. And NASA will continually sending missions to answer these questions. So this is what we found out so far. We learned that from previous missions, we learned that methane level on Mars changes CH4. Why it is important here? Yellow and red mean high concentrations, and then green and blue are lower concentration. When methane level change, what that means is something is producing methane. We know that on Earth, most methane come from living organisms on Earth, such as cow poo or when you fart. So also we learned this. Notice this. Something's flowing. We Mars orbiters took these pictures. What do you think? Do you think this is a sand or water? How about this picture? We call this line, you see these lines? We call this line the recurring slope, linear. What that means is season after season, it appear and disappear. What force do you think make this line? Do you think it's a flowing sand or water? I believe water is the one, flowing water is making this line. If there's a flowing water, that means the chance that life exists go high. It increases, really. So notice this picture. This is a picture from Mars. This is a picture taken by currently operating rover Curiosities. You see this pebble? What force do you think make this smooth pebble? We could assume that it's more likely flowing water. This is Earth. Isn't it so isn't Mars looks like a Earth? Pretty close, isn't it? So we know that this is strong indicate that there's a water, liquid water, not the frozen water on Mars, which is a strong indicator for possibility for life. Chapter 5, Mars 2020 Perseverance and Sample Return. This is the Mars 2020 Perseverance. This is about 900 kilogram robot, pretty huge. Because of its size, it requires a lot of energies. So it's powered by nuclear power, plutonium-238 dioxide. And Mars 2020 will focus on checking whether Mars was a habitable environment. We try to find out any sign of life, and we'll collect a sample, and we'll prepare for human missions, understanding any hazard or resource on Mars. Through several missions, NASA continually improved technologies. So Mars 2020 have a better way to landing, accurate landing site by taking distant photos, and it's comparing the picture with actual map, and it just take the course so that it accurately landing on designated site. Sky crane is one big picture. This is in the past we used a balloon, but this is so big, balloon's not going to work out well. So once Mars 2020 land on the Mars, it's going to drill the dirt to collect the samples, and helicopter Ingenuity will guide Mars 2020 for better navigations. And Mars 2020 will visit several landing sites, and you see here, you go there, you collect the sample here. Check this out here. Collect the sample, go other place, bring the sample back. It'll store the sample in one place. And put the sample in this small cylinder. So here, it's gonna bring the sample in one site. So that's what Mars 2020 gonna do for sample collections. And after that, future missions, follow missions will bring the sample back to Earth. So a small transport, the rover will take this a cylinder, collect it, and it's going to bring back to mother spacecraft. From there, we load it, we put the sample to out of space. So then this rocket will, pass this container of the sample to a waiting spacecraft. And this guy will bring back the sample back to Earth. It'll throw the sample to the Earth atmosphere, and more likely the sample will land on somewhere on Utah, it has a soft dirt, so that we don't want to smash it. So more likely it'll drop one somewhere in desert in Utah, in the United States of America. So this sample will help us to better understand and to prepare for Mars missions, Mars human missions. So researcher like me, I've been involved since 2015. I've been involved choosing human landing site for Mars missions, Mars human missions. So this kind of data sample will help us understand what are the hazards, what are the resources when our future Martian arrive on Mars. Number 6, landing site. This is a Mars. Red and yellow mean high elevation, such as red and it's a kind of mountains. And the green and yellow, blue indicating low elevation, such like a valley or bottoms of a lake or bottoms of ancient oceans. So, but you notice that all the past missions of NASA's missions, successful mission, they land on what color side? They land on blue and green. Why is that so? Why this lower elevation site? Because the purpose of missions is finding evidence of life. If you're looking for evidence of life, more likely we know that wind and water will bring material downward. Of course, if life ever exists, I think the evidence should remain bottoms of the oceans and lake. That's why all the previous missions is heading to a lower elevation area. So 2014, since 2014, we prepare for, the scientists all over the world got together, prepare for landing site for Mars 2020. So we start to wonder where we should send this new machine, this $2.3 billion machine. So this started a landing site, a candidate landing site scientists chose in 2014, since 2014, at the second meeting. And then 2017, the second meeting, third meeting, at the third meetings I attended, we finalized 3 landing sites. Number 1, the Zero Crater, which was, you see here, you see here fan delta here? You could sense that this is ancient lake. Ancient lake, right? Yeah, we could see that this is ancient lake. So this is a clay. You know, clay is what contain a lot of organic material on Earth. So it's a strong candidate site. And then northeast Syrtis, this is about hot springs. So hot spring means, Mars is cold. Then, the warmth could host life. Columbia Hill is the visiting site by the previous mission by Spirit rover. And we found a lot of interesting things here. So these were the 3 candidate sites. What do you think the perfect landing site for Mars 2020? Where should we stand so that we could find the evidence of life? So final landing site for Mars 2020 is the Zero Crater. Yes. So in February 2021, Mars 2020 will land on this ancient lake's bottoms. Okay, lake bed. So here it's going to collect a sample. We are going to bring the sample back to Earth. All right, so our future. So now I want to read Konstantin Tchaikovsky. He's a father of the Russian rocket scientist. He says that about 100 years ago, the Earth is a cradle. Cradle means this is where we put the young babies. Cradle for humanities. Yeah, this Earth was a cradle for humanity. We humanity only live here for a long time. But mankind, we cannot stay in the cradle forever. What does that mean? About 100 years ago, he says, we have to explore the space. We have to explore space. That's what he was arguing. Anthropologists believe that many, many, many years ago, our ancient humans ancestor, they bravely start to move out from Africa. So we call that out of Africa theory. And they went to humanity settled down different part of the world, right? Just to where here is what a lot of you, Korea. Here, this is the area for where you guys in UAE, you are including these regions. And I think so too. I think it's a time to move out of Earth. NASA is even thinking about terraforming. This is terraforming. Now Mars is a very inhabitable at this point for human, very, very hostile environment. But I think we could bring this one back to life. We could terraform Mars so that it's like a living environment, habitable environment like Earth. I know it sounds like a scientific novel story, right? So you wonder, is it possible? I'd like to ask you this. About 12,000 years ago, 10,000 BC, here in Los Angeles, where I live, there used to be a lot of mammoths. The mammoths live with the humans together. So here's the evidence that we have a museum in the Los Angeles that has a lot of the mammoth bones. I wonder, so now here in same regions here, 2028, we have NASA Jet Propulsion Laboratory making Mars 2020. We have SpaceX, we have a Lockheed Martin, Boeing, Aero, Lockheed, and the Northrop Grumman, which are space exploration leaders. They're all located here. So I wonder whether this ancient man ever could possibly imagine our current lifestyle, like space exploration or long distance communication, just like today's talk. Could he possibly imagine our current lifestyle? So I'd like to ask you a question, the same question. How about 10,000 years later? How about 10,000 years later from now? Can you possibly imagine how our future generation will live? Maybe travel through the wormhole might be the standard way to travel for our future generation. Maybe a quantum leap, just like our driving or flying is what our standard way of travel. Maybe we think it's impossible, but just like our ancient man could not possibly imagine our lifestyle, I don't think we can fully predict how our future generation will live. So why Mars? I suggest let's go to Mars first. And I think whatever we learn will give a very, very good foundation for our future generations so that they can explore maybe potential new home, such as exoplanet Kepler 62-e. So I'd like to finish my lecture reading the great mind Stephen Hawking's quotations. We explore because we are humans and we want to know. Okay, so this is the end of my talk.
Thank you so much, Professor Paul Yun. And can you turn your mic and camera, please? Yes, thank you, sir. There's a lot of questions that I have. So can I ask you some questions? Yeah. The first question is that the students in high school sent it to me. That he said that I am very interested in space and especially space engineering.
Mhm.
And I am studying basic sciences such as physics and mathematics while, while also reading related books. But however, it is not easy to do many activities related to this field while I am high school. So what kind of activities and studies would be beneficial at this point and before entering university or a graduate school?
Okay, so I think you know what? I got this question. So can I share my screen to answer these questions?
Yes, of course, sir.
Okay. All right. So let me answer the first questions. Here we go. Okay. So this was the questions. Everybody's. Okay. So uh, I am very interested in space, especially space engineering, and I'm studying basic sciences such as physics and mathematics while reading related books. However, it's not easy to do many activities related to this field while I'm in high school. Yeah, I understand it. Actually, I was in I immigrated from Korea to United States when I was in high school, 1986, many about more than 3 decades ago. So, what kind of activities, studies would be beneficial at this point before entering university and graduate school? Okay, so I thought about it. This is my answer. I say find a field. I think you know what? You could find one field of mathematics and science that interests to you, and then explore. Nowadays, we have so much resource, right? I mean, you go to online. I mean, you could find out everything there almost. So I suggest read book. You know, if you find find a field, right, something interests you. Find a book and article. That's something you can do. And then visit a website or watch YouTube or movie documentaries and visit science museums. I know it's a general thing, right? But I suggest you focus on one topic that really interests you. I think if anyone want to be a scientist in NASA, I think you need to have a curiosity on some topic, and you need to explore for in depth. Okay, that's important characters you need to have to be a NASA scientist, right? Choose one topic, focus, and then explore, and attend the lecture and such as our talk. You could build a model. This is my suggestion too. The example is such as like Sir Isaac Newton. He was very successful. One of the reason is because while he's solving a math problem or physics problem, he also was really good at building model. See, he was very good at visualizing concept, and this is one of the key reasons why he could be so productive. So Isaac Newton's write
Okay.
articles, right, and publish books, and join or why don't you start communities? If there's no club, such as a campus club, so you could share your idea with your friends, right? Especially if you're considering to go to university, then talk to professors. Why don't you contact them in the field of your interest at the university you plan to attend and learn about their research? I suggest be creative. You know, find your own way and then do it whatever you can. I can say there's so many things you can do. So I want to say while you are exploring, it's not the point of you finding some result, great result. I think Einstein said something very important. The important thing is to not stop questioning. Keep questioning why. If you have a question, wonder why all the time, I think you have a very important character of being a successful mathematician or scientist. Okay, that
Yes,
was
sir.
my answer.
Well, thank you, sir. So, Professor, can I ask the question on the chatting?
Uh huh.
And so, can I ask the question that you just get and the new question on the chat and
Uh
alternately?
huh. Okay.
Yes. The first question on the chatting is that are we able to recreate or fix the broken and hazardous atmosphere of Mars to be colonized?
Okay. So let's see. Could you repeat one more times?
So, are we able to recreate or fix?
Are we are we are
Able to
we able to recreate
or fix
huh?
or fix
Or fix
yes or fix
uh-huh,
the broken
the broken
and hazardous
okay hazard okay hazardous
atmosphere
atmosphere
of Mars
of Mars
to be colonized.
to be colonized. Yes, that's what so-called terraforming, right? Colonize. Okay, colonize. Yes, you're right. Actually, this is a very important question. We know that the inside is what one thing we send out. Currently, there's a currently we have a satellite orbiter. Maven. This is NASA's what another currently operating the orbiter. We try to understand why Mars used to be about more than 3 billion years ago. We think that Mars was like an Earth, but somehow its its magnetic field kind of turned off. You know, Mars is like inner planet like Earth, so they had iron. Somehow it's turned off, and then their magnetic field issue was magnetic. We know that their magnetic field was turned off.
Mm-hmm.
So magnetic field turn off. Magnetic field is the best way to protecting solar wind. You know, strong solar winds. So when our defense system was broken, Mars what magnetic field was broken, and it destroyed what the Mars atmosphere. So that's why all the what it become just barren. So what we're thinking about is what is it terraforming? We think that NASA is thinking maybe possibly why don't we make some? This is the sun, this is a Mars. Why don't we make some sort of some magnetic field force like this so that you naturally create a block of the solar wind. And then what we think is we have a lot of as you mentioned, there's a lot of carbon dioxide frozen. I think when they release, I think we could warm up the what Earth atmosphere.
Oh.
Then we could use greenhouse effect. Greenhouse effect. You know that CO2 is really bad for Earth, but if you really want to terraform Mars, we need CO2. We need a greenhouse effect. And I think we can increase the temperature. Then later we could bring the what plants, all those things. This is our strategies. So I think you're right. I like the words broken atmosphere. You're right. Somehow the Mars atmosphere was magnetic field was turned off, and then it was destroyed. And I think we believe we can do it. When it may take hundreds of years, but we know that we should never underestimate the possibility of humanities. Our future generation, I'm pretty sure they will be able to do it. And personally, I feel that if we succeed terraforming Mars, we could continue those terraforming other planets too. I hope I answered your questions.
Really,
Next
thank you,
question.
sir. And the second question is that you already get is that I would like to know the
Uh
Professor
huh.
Ho Yun's opinion on studying abroad in the field of aerospace engineering. And if there were certain things to do to prepare for studying abroad, I would also like to get to know more about NASA and the path it took him to achieve to getting into NASA.
Uh huh.
Lastly, I'd like to know what NASA is mainly focusing on these days, except for the Mars missions, and the direction for the next few years.
Okay, that one. All right, here we go. That one, I got the question, so I prepare. All right, so I think this is from Min Hyuk Kim. All right, so first question was, I would like to know Professor Yoon's opinion on studying abroad in the field of aerospace engineering, and if there are certain things to do to prepare for studying abroad. I said this part B. I would also like to know more about NASA and the path it took him to achieve getting into NASA. All right. And third questions. Lastly, I would like to know what NASA is mainly focusing on these days, except for the Mars missions, and the direction for next few years. Okay. So let me answer these good questions. Answer for A. If I were you, I would learn language regardless of whether you study aerospace engineering or literature or history. if you plan to study abroad, I think the first thing you need to do is about learning language and culture of the countries where you plan to study abroad as much as you can. It's important that you get along with people there. Why? So I'm just emphasizing one more time. Understanding culture, language is definitely the first step. Anyone planning to study abroad, learn about the countries where you plan to go. Why? You want to be a friend to your peers, your professors, your neighbor in this new environment, right?
Mhm.
Then they will welcome you and you will get their support. What does that mean? With support, without support, the chance you succeed is very different. With their support, which consequently increases your chance to complete your education. So that's why I think, regardless of whatever you study, you plan to study abroad, master, try to learn as much as you can. You don't need to be perfect, okay? But try to learn their language and culture first.
Mhm.
Part B, I'd like to say introduce. I don't know anyone heard about this Dr. Jaewon Shin. He actually educated in Korea. He graduated from Yonsei University as a ME mechanical engineer, 1982, and then he came to United States. I think he's attended Cal State Long Beach. This is about my house is about 30 kilometers away from Cal State Long Beach. He got master's and he went to Virginia Polytech for his PhD in engineering. So mechanical engineering. So he became associate administrator for NASA and aeronautics. What does aeronautics mean? This is the second alphabet here. First A, this is standing for National Aeronautics. Aeronautic division is in charge of airplane, anything flying in the air. Research and mission director. He was number two man. When? This many years. So look at him. You know one thing I can you say? Can you see his smile? I think the secret of the Dr. Shin's success was his personalities. Yeah, I mean, you need to study hard, but I think he knows how to bring the people together, right? And then he's not Native Americans, but he could reach this top of the leadership position. Currently, he retired. He's been in NASA more than 30 years. Now he's currently executive vice president of and head of the Hyundai. Hyundai is currently thinking about urban airplane. I know they're making electric vehicle, hydrogen vehicle, but they're also thinking about making flying aircraft. I mean the vehicle. So he's now currently leading Hyundai's urban air mobile mobility divisions. So he's a good example.
Mhm.
Uh, I'm pretty sure he did his best when he came to America, and then smile, teamwork. Especially if you plan to come to the United States, thinking about working in a place like NASA. NASA really value high teamwork, teamwork, right? So while you're in school, get involved, right, and train yourself so that you become team player. Next one. So what's going to be NASA's focus? So this is a very important issue. You are currently about you're teenagers, right? So by the time you become 60s, think about it, you're becoming 60, okay? When you become, when all of you guys, when you become 60 years old, 60 years old, okay? Imagine you're 60 years old, your grandma, grandpa's ages. What NASA gonna do is, NASA next 50 year, we're gonna focus on this green section. See, we are in our solar system, Mercury, Venus, Earth's moon, and Mars's moon here. I talk about this. Check mark mean these are the one we did. We actually did all the flyby. Orbiter, we did it. Lander, we did it. Sample return, we know the only place we did it was Earth, for NASA's case, moon missions. But these are the green section we need to explore. So we're going to explore here.
Oh.
Mainly what we're interested about understanding each planet. So to unlock the secret of the universe, I think the best way is to bring the sample back home. Yeah, so next 50 years, until you become 60 years old, we'll continue to focus on bring the sample. And
Mhm.
then outer planet, gas giants, that Jupiter, Saturn, we haven't explored that much, right? You notice that only thing we've done is a flyby, pass by. So we think we know a lot, but we haven't explored that much. Again, we focus on sample return and all the other orbital lander, it's got to head to different places. So these are the places we are going to explore for next 50 years. Okay, so I answered
Thank
your
you so
question.
much. For the third question, I heard that the Perseverance will bring the sample of Mars, and what is the specific process of that? And I simply know that it is a way to send another spacecraft to Mars and connect, and it to Perseverance or something else send it back to Earth. It is correct?
Yes, that is correct. That is correct. Okay, so here's the question. Let me repeat again here. Perseverance will bring the sample of Mars. So you already watching my lecture. Yes, it does. So what is the process? So let me explain one more time. Yes, the way is what we're gonna send another spacecraft. We are currently NASA is working on. So one of my friends is currently the engineer, mechanical engineers involving Mars 2020s. He's currently working on sample return mission too. So NASA is what we haven't set the date yet, but sample return mission is on the way. We are planning out. The NASA is working on next missions. I mean, currently what Perseverance is heading to the Mars, but sample return mission is now on the track. We are preparing. They are now putting the idea together, but it'll take a years. But we don't have any set date. Okay, so so let me go over this one more time. So as I say that, so March 2020, step one, March 2020, what is March 20 Perseverance job? Going multiple place. This is the zero creator, right? This is we saw that fan delta, ancient lake. Yes, all dry because that was a problem when the atmosphere was broken. Solar wind came and it just took away all the waters to out of space. That's why all everything dry like a desert. So it's landing side and they collect all the sample here, going multiple place. You want to go multiple place so that we have a higher chance to get more information about the Mars third. Um, Also, what the one thing I want to say is what this is what UA's what UA's current uh, the orbiter's mission too. I try to understand dust storm. Dust storm is a pretty important issue. I've been involving this. I one of my papers about NASA is about dust storm because when we prepare human mission, unlike what the UA's what the sand, that your UA student in your UA you guys have a lot of sand there too, right? Martian dust is so fine, and then when you inhale, it's really hazard. Dust is a serious problem. Problem is once we build the human habitat, dust is
Mhm.
gonna penetrate and it's gonna contaminate the human habitat. This is what we get freaked out. So NASA is now currently we're really worried about this dust storm. So we have to understand before we send the human, we have to understand dust impact on
Mhm.
human mission, also mission too. So just keep that in mind. Unlike Earth, the sand in the UAE, the Martian dust is very, very fine, very, very harmful when you inhale. And we think this is some of them was contain the cancer-causing hazard material. So that's what once we bring the sample back to Earth, we will understand better. That's a step one. Step one, so collect the sample here, right? That's what then Perseverance jobs is done. And then the next mission, currently we are NASA planning. We haven't set any date, but this is what we're going to do. So again, what do you do? Step three is we send the next mission. Step three is bring the sample back
Mhm.
to mothership. Step four, what do? We put that into the rocket
Mhm.
and take it out of Mars atmosphere. And then this guy will pass a sample to, there's a waiting spacecraft will be waiting outside here. Okay, it's going to wait there. And it'll catch it and it's going to head to Earth. Here we go. Then once you get there, it'll throw the sample back to Earth atmosphere. That's step six, and it's
Mhm.
going to land it here. And then we're gonna pick it up. So this is a step. All right.
Thank you, sir. And this is the last question that we prepared for you. And
Mm-hmm.
why is the sun's corona so much higher in temperature than sun's surface? And what specifically does Parker,
Mm-hmm.
the probe currently approaching the sun, do?
Okay. So this one, once I get this question, again, I am a the Mars expert, but this is for heliophysics. We call this heliophysics, which is about heliophysics. It's physics involving sun. So I'm not the expert, but I did my best research to understand it. NASA has done several things to understand why. Here, okay, so here's the thing. Let me help many of you. Why this question is interesting? Yeah, I was surprised too. Why the sun's corona? This is a corona. This corona means the sun's atmosphere. See, this is the what during the eclipse, right?
Yes.
Eclipse. So we took the sun, we blocked the sun. This is what this is a corona here, outer regions.
Mm-hmm.
Interesting is this is hotter than inner part, the source of the heat. Source of what heat is what the from the sun, right? It's
Mm-hmm.
quite intuitive because I put the what this campfire. You know that if you're farther away from the sun, it is a cooler. Sorry,
Mm-hmm.
here's a hotter. Obviously, source is hotter, and outside the cooler, isn't it? But contrary, I mean, sun case, outer is
Mm-hmm.
hotter. How could that be?
Mm-hmm.
Outer side is hotter, the hotter. So I think so far scientists we don't have any definite answer yet.
Yes.
So we, in general, scientists agree that there might be many reason why. So one of the well accepted argument is this is called the plasma wave. This is sun's surface, inner part, and when the plasma wave is shoot out to the what corona, it hit and smash, and it release energy. So it's like depositing the what money to the bank. It deposits the energy inside the corona. I think this is one of the well accepted arguments. So that's why outside become very hot. Second is this is what 2015 NASA actually previous missions. This is what NASA's what terminology. So we call it nano player. Nano means very small. Nanotechnology, very small, right? It's a think of the small firework, small heat bomb. It's due to a magnetic field that increases the temperature. So what happened is outside here there are a lot of small firework, you know, a lot of firework. It's due to magnetic field in the corona. So this is a well the accepted arguments, even though we're not for sure of 100%. So this is how. Here's another thing here, folks. How does NASA get to the next mission? We wonder. We don't have a complete answer, and that lead to the next mission. This is NASA style. It's not Gangnam style. It is NASA style. What is the NASA style? NASA style is we want to know. I think we think this is the one, but we're not quite sure. And NASA style, hey, let's go and let's find it out.
Mm-hmm.
That's a NASA style. So the second question about what does this Parker? Parker is it's a probe. It's a spacecraft. Currently, it is heading to the sun. I think the Parker will continue next couple of years. Will continue. It's already there. We launched it in 2018. Parker will continually get there. Parker will do this. It's going to try to understand why corona is hotter than solar surface. We try to understand more definite reasons, and then we try to understand what force drive a particle plasma into our solar system. So that we survive. You and me, we also because thanks to solar energy, right? Yeah.
Mm-hmm.
So what makes this plasma and particle is what move into the solar system. So by getting the data about the particle, solar wind plasma, electromagnetic field, solar radio emission, and the corona. So then you may say, who care about this? Who cares about this? Why do I care? Why do I care, right? Hey, I mean, how does it affect my daily life? It does really affect your daily life. Have you heard about what space weather? Sun, sun's weather. This is what really done. A lot of research done by also in the Korea's 한국천문연구원. Uh, they what space weather does. It could damage when there's a strong understanding solar sun's behavior. When strong solar wind come, it could damage satellite. You see satellite? We have a lot of satellite. Yeah. Why we care about this, especially nowadays? Earth. You know that our navigation, flying, your communication, everything depending on satellite, right? Strong solar wind can damage the sky. And then, can you imagine we're flying and then suddenly we get lost, we lost contact, or all the communications? Yeah, it's really heavily depending on this kind of satellite. Um, so that's why it really affects our life every day. So that's why we're sending this Parker to the sun. Okay, so I answered the questions.
So really, thank you, sir, and I really appreciate for your good reply. So can I ask some more questions if you have a time?
Oh yeah, sure. I have plenty of time. Any other question? Okay, you guys ask me any question. Please turn on your camera, and then I'd like to see you. And then please say your name, and then ask me any questions.
Yes, everyone, attendant, can you turn on your camera
Can you guys turn on the camera, please? All right. 혁준, hi. All right, Mizna, hi. Susong, hi. Dae. All right, Minhyuk. Chongwan, good to see you. Minseok, Gummo, Mohammed, Hamad, everybody, good to see you. Dr. Ju, sorry, Dr. Lee, I couldn't attend your meeting, sorry, but thank you for coming to my talk. Thank you so much. Okay.
This is the question on the chat.
Yes, I'm here.
Thank you so much attending my meeting. You know what? You guys could ask me also a question in the chat too. I could read the chat.
So can you answer the question that Kang Hyuk-jun students will send it to you? That can't we take samples on Mars by using method used to get specimens on asteroid?
I think so. I think that's a very, very important question. Actually, that's very important. 1970s, we were very excited going to the Mars. We thought that there were life there. But when you sent Viking missions, 1975, we realized Mars was really barren. There was nothing there. So we were very discouraged. And in 1980, we didn't even send anything there. NASA literally gave it up. But 1996, at the time, when he sent the Pathfinder, first rover, President Bill Clinton at the time in the United States, we had a fossil from Mars. We thought it was like some fossil. We don't know yet, but that was kind of motivation why we end up going back to Mars again, 1996. So yes, I think easy way is if there's some, but the problem is this one. Another thing is what if there was some part or any rocket coming to Mars to Earth, then I think while they're traveling to space, they might be contaminated. This is another important thing. Next 50 year, we worry about sample return is a very important main thing for NASA's missions next 50 year. Okay, we are going to go to different part of what, Saturn's moon, asteroid. We go everywhere, but while we bring sample back home, it may be contaminated. That's pretty important. Something we have to watch out because space weather is such a strong radiation, it could contaminate. So I think it's better to bring sample back. It's a very if we put in the safe can, that's why we put the sample in the small container so that it doesn't change. It's like suppose you have food and then you bring it and it all spoiled, then how are you going to eat, right? Something like that. Okay, I hope I answered your question. Next questions.
Teacher, but there's a lot of questions that we will ask to you, but because of the time some constraints, so we have to wrap up here. So everyone, please thank you to Professor Paul Yin, and you can turn on your audio and says thank you for Professor Paul Yin, please.
Well, thank you so much, you guys. Yeah,
thank you so much.
Yeah.
Thank you.
Yeah, can you guys thumbs up if you enjoyed my lecture?
Thank
Can you
you.
thumbs up if you understand my lecture? Anyone enjoyed my lecture? Please thumbs up. I need your feedback. Thank you. All right.
Thank you so much.
All right, Christian, everybody, thank you.
And thanks for everyone. And I really thank for everyone who attended for this good program and for everyone who do a good lecture for us, Dr. Juhi Lee and Mr. Abdullah and Professor Paul Yin. All three of them, I really appreciate for your good lecture and good reply for us. And really thank you to everyone who gave the lecture and once more time, and really who attended for this good program today. The lecture will be uploaded on YouTube by the Young Astronauts Korea after participation through the online platform and Zoom meeting, and shared as the educational video resources for both countries. Thank you for your hard work, and this is the end of the program. Thank you.